Hi, I'm Dave Dugan. I'm the president of Ebtron, and I'm going to give you a short presentation today on why we need to measure airflow rates and then why we should choose Ebtron. This is really the first of a series of presentations. I call this a teaser presentation, and you'll find that we'll be able to get into a lot more detail in subsequent presentations, but this is just like an overview presentation. So basically on the why measure airflow rates, I've broken it down into these 5 categories, okay? One is to improve indoor air quality. The second is to demonstrate compliance with codes and standards. The third is to control airflow rates and thermal comfort. And the fourth is to save energy. And the fifth is, if we get back into a pandemic situation, to facilitate switchover into pandemic modes. So let's talk briefly about each one of these, okay? So when we talk about the benefit of improving indoor air quality, we've got some really nice presentations on this, but basically the overview of what we want to be able to do is we want to make sure that everybody understands that that basically a prerequisite to indoor air quality, acceptable indoor air quality, is that you have proper dilution outdoor air. Okay, and so we're going to want to make sure that we get everybody to understand why that's important. It's also combined with filtration, and in some cases, depending on what's going on, we may add some other things to basically, if there's viruses, kill the virus, and so on and so forth. But for the most part, for general indoor air quality, we're talking about outdoor air for dilution and filtration. Our expertise is outdoor airflow measurement, so that's what we'll focus on. If you look at the industry, there's a number of standards that all specify these ventilation rates. We got standard 62.1, which is ventilation for acceptable IAQ in non-healthcare facilities. For healthcare facilities, we have standard 170. We also have a standard 189.1, which is the standard for the design of high-performance green buildings, which is also the IGCC. And now recently, we have standard 241, which is control of infectious aerosols, which I think is really important, and I'm pleased to see that ASHRAE's actually done something there. I put this little statement down at the bottom. This was actually a pre-COVID statement from Lawrence Berkeley National Laboratories. It stated that U.S. employers could benefit $7 to $15 billion per year in workplace productivity gains from providing proper outdoor air ventilation. So you can imagine what it is today. There's basically, when it comes down to looking at dilution ventilation, our opinion is the only way you're going to pull this off is you need to measure it and control it. And we're not the only ones that feel that way. So when you take a look at this particular slide, you'll find it ASHRAE 62.1, the 2022 version. Their Appendix L, which is for existing buildings, says that you need to measure to determine whether you're in compliance, measure system outdoor airflow rates, and it allows you to either directly measure them in the field, or use permanently installed calibrated airflow meters, which is what we would prefer. The IGCC, or ASHRAE 189.1, also has a monitoring requirement for outdoor airflow rates. If you're in California, and California Title 24 does propagate in other parts of the country, there's a requirement that outdoor air be certified to be within 10%, and also allows the use of permanently installed calibrated airflow meters. And I just put LEED up here as one of many, rating systems that also requires outside airflow measurement. LEED for VAV in most buildings, healthcare, it's for all systems. I think that's fairly important. Another benefit that we can talk about in some detail is to improve indoor air quality is maintain compartmentalized building pressure. Now, I can't really get into what compartmentalized building pressure is in this short presentation, but overall building pressurization is very important to indoor air quality, and it's that we want to limit the transport of untreated outdoor air into the building. That happens when the building is negative, okay? And if we're in moist climates, negatively pressurized buildings really have moisture problems from pressurization that can result in mold growth and causes thermal comfort problems, humidity control problems. And we want to be able to talk about that. In addition to pressurization, you also need to maintain your flow rates because you don't want to bring in too much outdoor air above water carryover limits of, say, louvers or hoods, because that's going to cause mold problems, as well as supply air flow rates. If you have too high of a supply air flow rate, you could have a water carryover, pan carryover problem. So those are things that we would talk about in another presentation. A big issue here, particularly for engineers, is to demonstrate compliance. And I want to make sure I make this really clear that it's not that you want to just demonstrate the code required outdoor air ventilation is provided when you turn this building over when it's first occupied. I mean, all of the codes, the IMC, the UMC, California's Title 24, whether it be Part 4 or Part 6, they all specify ventilation rates, okay? As do the standards that we just briefly spoke about. The big thing for me that I want to make sure that I impress upon everybody is that it's one thing to show that you've complied with the code required ventilation when the building is first occupied. It's another thing to be able to show that the building has provided the code required ventilation or more during operation, because when you get into these buildings, a lot of times the owners will change the way the building operates, or the control people will change the way the building operates. And if the building gets into any kind of litigation down the road for air quality, you want to be able to demonstrate that, that either the building is providing the code required ventilation for outdoor air, or somebody changed it, okay? And I think that's an important reason to always monitor outdoor airflow rates. So that's really, we have a nice series of presentations again that talk about specific requirements of codes, and you might want to drill down a little more and take a look at that. Another benefit, we talked about control airflow rates and thermal comfort. Basically, we can demonstrate to you that if you don't measure and control your outdoor airflow rates, particularly on recirculating air handling units, variable speed, VAV, variable speed or constant volume. I mean, basically we can demonstrate that fan speed variations, wind speed and direction, stack pressure even on low rises, damper issues, really all will result in significant variations in the outdoor air that comes into these units. It's also true on DOAS systems, but the dynamics are a little bit different, okay? Either way, we really believe that it's not just monitor for monitoring, it's monitoring for control. And we would show you that direct measurement really is a superior way to do it. There's some calculated methods that folks use from time to time, like delta CFM or temperature mixing. They don't really work. I'd like to be able to demonstrate that to you. All the indirect methods, there's a lot of methods out there right now that they require field setup by test and balance. And it's nothing against test and balance folks. We have a challenge of measuring in a lot of these outdoor air intakes. Test and balance professionals have even a greater challenge. Sometimes they have to measure outside of the unit and the flow rates are very low. It's very difficult to get accurate measurements, and because of that, these field adjusted or field calibrated techniques can't be any better than what they're calibrated to. So again, we got a nice presentation. If you're interested in this, join us for that presentation down the road. Also for the control airflow rates and thermal comfort, we really want to get into specific control strategies. Basically, we believe in all airflow control strategies. That means we're going to control outdoor air for dilution. We're going to control differential flow rates, or the difference between supply and exhaust flow rates, for pressurization. We want to make sure that we have the instrumentation in place if you have an airside economizer for proper switchover there. So we're going to get into that. And detect system faults. Not enough. There's a lot of systems out there that simply aren't performing, and the facilities folks just don't know it. And so when you have this instrumentation in place, you can detect system faults such as damper binding, economizer malfunctions, control issues, fan failures, even coil performance problems, okay? And we want to get into that with you and show you ways to use our devices to really improve the operation of your system. And save energy. I like this slide a little bit, stop blowing money. I mean, basically, if you're not controlling your outdoor air intakes, you're blowing money, you're wasting money. You're either bringing in too much outdoor air, which is really on the energy side that what we're talking about, or you're not bringing in enough. Now, the too much energy, too much outdoor air from an energy perspective is a no-brainer. Outdoor air is the most costly part of, uses the most energy in an HVAC system. So you want to make sure you bring in the right amount of outdoor air, but you don't want to bring in more outdoor air than you are desiring to do, okay? And CO2 is another area. It's an area that I've worked on for 30 years. I have some really good presentations, try to get people to understand some of the problems with CO2 ventilation control, some of the misconceptions on CO2 ventilation control. I mean, basically, not enough people understand that CO2 and outdoor airflow rates are basically codependent. You can't really speak about one without speaking about the other. And that when you're using CO2 to control your outdoor airflow rates, you're really making a lot of assumptions. You're making assumptions on the CO2 production rate of the occupants, which is based on their age, their activity level, among other things, their weight. There's a lot of issues here that are ignored. We find that if you do CO2 DCV, you really should be using airflow measurement to set upper and lower limits. We have ways to use airflow measurement with CO2 to estimate the population, which is a really good way to comply with the actual requirements of Standard 62. Again, I can't get into it in any detail in this short presentation, but I think it's very useful and very important for people to understand. I also think that there's a valuable discussion we can have about why are we measuring CO2 in the first place when what we really care about is the dilution ventilation. Maybe we should be setting these dilution ventilation rates based on measured occupancy. So we have nice presentations there. That all falls into saving energy, but I also could put that into improving indoor air quality. It depends on how you want to look at it, okay? And then, you know, this where we are today, COVID really should have changed a lot more of the thinking than we have changed, actually. And I always had called this pandemic mode switchover, but ASHRAE has really put together a term that's a little more general, because it doesn't have to be a pandemic, actually, to worry about, airborne infectious disease. And I think that's why the wording is here, not just pandemic mode, and they call it infectious risk management mode, or IRMM, okay? So I'm going to say the benefit here is facilitate that. And, to do that, you have to have a robust control system strategy with measurement that allows you to switch from a normal operating mode to this IRMM mode, okay? And when we were in COVID, which personally, we're not really out, my opinion is we're not out of COVID, but that's a whole nother discussion. The CDC and ASHRAE recommend increasing outdoor air ventilation rates and disabling DCV during a pandemic. That's not that easy, okay? If you're not measuring it and you don't have a control strategy that allows you to do that. So we can talk about how we want to do that, all right? And that's basically increase the outdoor air flow rates, but have a way to control it, monitor it, and know that you're not bringing in more than the system can provide. Okay, and so I have a nice presentation on that I'd like to talk about for those of you that are interested in that. Okay, now, to me, those are the main reasons why you want to measure airflow rates. Now, I've left out laboratories, I've left out clean rooms. I pretty much didn't really get into healthcare. I mean, those are all areas that I think are real clear cut that you want to measure airflow rates. But these non-healthcare facilities, we find folks trying everything they can to do something different. And that's why I want to spend the time on those 5 basic topics and drill down more for you if you're interested, okay? Now, once we've done that, we get into the Ebtron products, okay? And when we get into the Ebtron products, I'd like you to understand a little bit about us. For instance, we started in 1983. I started in 1984. I still have people that are working with me that started in 1984. Okay, we've been there a long time. We have a lot of experience. We're a privately held company. We haven't changed ownership. We haven't changed personnel. I think that's very important, okay? We basically pioneered direct outdoor airflow measurement in the late 1980s. I remember working on it with my partner, Mike Urbaniak, who I still work with, and we worked day in and day out to come up with a way to measure outdoor airflow rates and control them, okay? Our technological advantage back then, it was our thermal dispersion airflow measurement, and it is today. It's what we still do, okay? We are a measurable difference. Now, I have a few slides here just to give you a quickie on Ebtron. I'm going to have a lot more detailed presentation available, but on the why choose Ebtron, I have 3 real good reasons for it. Number 1 reason is performance, the number 2 reason is quality, and the number 3 reason is value, okay? And on the performance side, basically we've been using this time-tested thermal dispersion airflow measurement 40 years. That's a long time, okay? Every sensor is independent, it's multi-point airflow and temperature sensing. Every unit is factory calibrated. The measurements are percent of reading, not percent of full scale. That we start our calibration from still air, so we can measure down to still air. That doesn't mean that you should try to measure an outdoor air intake at 20 or 30 feet per minute, because there's other factors that get in the way. But in terms of our ability to measure, we can measure down to still air. We have a wide temperature operating range, wider than you're going to see in most of your HVAC applications. We have very long-term stability. The parts that we use are extremely stable. Okay, we have velocity weighted temperature measurement as a standard feature. People think of us as an airflow meter, but we are an airflow and high performance temperature meter. All right, we also have the ability to add a humidity sensor and provide velocity weighted enthalpy and velocity weighted humidity, as well as dew point from one of our airflow meters. Okay, we have a lot of connectivity options for you. We have analog outputs, isolated analog outputs, RS-45, Ethernet, LAN. We've got you covered from a connectivity perspective. We have a nice little phone app, we call it the EbLink, okay, which is a low energy Bluetooth device. Okay, we don't charge for it. It comes with every one of our Gold Series units. Okay, again, a measurable difference. Quality, 40 years. We didn't just get into this yesterday, okay? We use these stable bead and glass thermistor sensors. They are important. We're the only ones that use it. Okay? Everything we do is calibrated to NIST traceable standards. We have independent test lab verified water and acid tolerant sensor nodes, meaning they can handle saltwater exposure and acid exposure. We have standard products are built out of aluminum, but we have other products that we can offer out of stainless steel. Our cabling between the sensor probes and the transmitter is all FEP polymer cable. FEP is basically a generic Teflon, very UV and temperature tolerant cable. We have a high performance transmitter. We have this advanced sensor detection system technology. It's a smart transmitter. It's looking at making sure that everything's working properly. If it isn't, it has a way to ignore the sensors, let you know there's a problem, and basically only use the sensors that are working properly. All of our integrated circuits and our transmitters are industrial grade. We don't use commercial grade parts. Industrial grade gives us more stability, lower and higher temperature limits, okay? Any interconnects that we have on all of our products are going to be gold plated. Our Gold Series product has gold plated pins on its connectors. Every product, every transmitter, everything we do goes through a minimum 48-hour electrical burn-in prior to being calibrated. And our testing facility is multi-stage test, automated test equipment in the manufacturing process. And we have a 3-year warranty, is our standard warranty on our products. In terms of value, sometimes people don't think they don't, or what do you mean? You're on a higher price of the food chain here. It's like, yeah, we are, but the big deal is that it works, okay? And if you actually, what you need to do when you look at the cost of an Ebtron, which not enough people do, is they need to look at the cost of the Ebtron solution as a square footage of floor area price in the facility you're putting it in. And you'll find it's really low. In fact, you'll find in many cases it's the same as using a CO2 sensor when you look at it per square foot of floor area. So when you look at the energy savings, the health savings, the occupant productivity savings, the return on investment is actually pretty fast on an Ebtron. We don't require costly periodic calibration. We have a toll-free customer service for the life of the product. It actually has this thing called a person on the other end of the phone that actually answers your questions. We have many of our products have been in service for more than 15 years, many actually more than 20 years. If you do get a product from us and there is a warranty issue on it, we have something called an advanced replacement policy where we'll just send you another unit before you send us one back, just to get you back on your feet. We do have to go through a little bit of troubleshooting with you to make sure that we're confident that it's a warranty problem. Big thing for us is we only sell this product through local reps because we know that you need somebody that you can call that can help you throughout the entire project, start to finish, and even after the project is done. I'm not going to go through a lot of the Ebtron product right now. I do want to make sure I've kind of said this a little bit on a previous slide, but we have a lot of connectivity options, isolated analog outputs, RS-45, BACnet MSTP, or Modbus. We have Ethernet BACnet or Modbus, and we have Longworks free topology, okay? The humidity sensor option, again, I just want to stress that we have it, okay? Gives you a lot of different things you can use this for. It's actually great for economizer switchover, particularly if you have an outdoor airflow meter anyhow. But this velocity weighting, you'd have to understand a little more why it's so important. But velocity weighted temperature applied to humidity and enthalpy is significant. Okay, and I can show you that in another presentation. We mentioned the basically the Eblink app that we provide free of charge for your phone. It basically will give you whatever you can see on the screen, on the display of the unit. It can go into more detail. If somebody adjusted the unit, we can actually turn off that adjustment. So you can see it on the phone, but it doesn't affect the control system. This is a read-only device. We don't want people taking down your system, okay? That second screen in there has traverse data. This product was originally, or this option was originally developed for test and balance people. It gives you individual airflow rates as well as individual temperatures of each individual sensor node. Very valuable to balancers, but it's also very valuable to anybody that wants to do some diagnostics on their system, see what's going on. And then we have basically a full diagnostics menu. Tells us, basically everything there is about the transmitter, what all the configurations are set to, any trouble codes, any active trouble codes, historical trouble codes. And the cool thing there is if you do have any trouble, it has that little send to Ebtron service. You just click on that and it will send it off. I will make a comment right now. This is only available for the Gold Series. When you order the Gold Series, make sure you give it a name. If you give it a name, that'll show up. If you look at that left-hand screen, you see the top thing there that says AHU5 return air. That's because somebody gave it that name, okay? It's supported by Android and Apple iOS, okay? We get into fan measurement. If it's a fan array, we have an additional screen that will give you the individual fan flow measurements. Real quickly, we have a very wide product range. So going from left to right on this screen, our top of the line, highest sensor density product is our Gold Series P probes. Okay, a lesser sensor density product that has very similar characteristics is the hybrid. And then the application specific line there on the right is the ebb flow product line. And really, we say that the Gold Series is the top of the line, but really for specific applications, the hybrid series would be the top of the line. For certain application specific applications, the ebb flow is the right one. And basically you just need to work through, understand the products are very simple, okay, and what's the right product for you, and hit the right price point. We also package it with the Tamco damper. We call it the Air IQ or the Air IQ 2. There's a few little differences. The Air IQ is the original one. It's a little wider. It's got a bigger flare than the Air IQ 2. The Air IQ 1 is really something we keep along. It's good for unducted, higher velocity applications such as unducted returns, maybe fan, exhaust fans, relief fans. The Air IQ 2 is really the product that you would use on your outdoor air intakes. When we get into fan mounted products, we have a nice variety of products there. We have a product that's well suited for the fan arrays, which is on the left. And then we have another variant of that product that's great for your single and dual inlet fans. What makes these products really good is that they're all adjustable. You don't need to know the exact size of the fan, and they do not affect fan performance if you selected the right product, and we'll help you do that. Okay, so that's our introduction. So hopefully this gets you interested enough that when you see some follow-up presentations that you basically want to learn more, and we'll get that out to you over the next series of months. All right, so thanks again. Talk to you soon.